some more problems on Euler's theorem. Verify Euler's theorem for the function u is equal to x raised to half plus y raised to half into x raised to n plus y raised to n. So u is this function, and then this function is a homogeneous function of degree 1/2 plus n. So if there is multiplication, then addition of the degrees. That is, degree of this function is half and degree of this function is n, and so degree of this total whole function is what? 1/2 plus n. So why this is? Because if you take u as this function, then u of tx ty. If you replace x by tx and y by ty, then we have this, and take this t raised to half as a common factor and t raised to n from these two. So we have t raised to half into t raised to n is x raised to half plus y raised to half plus x raised to n plus y raised to n, and that is t raised to 1/2 plus n, or n plus 1/2, and this is u of xy. The remaining factor is u of xy. This function is u of xy. So u of tx dy is t raised to n plus 1 by 2 uxy, and therefore this u is a homogeneous function of degree n plus 1/2. So if there is division, then subtract the degrees, and if there is multiplication, then there is addition of the degrees, like the logarithmic function, that is log a into b is log a plus log b, log a by b is log a minus log b, like that. So the degree of the homogeneous function is n plus 1/2, and therefore by Euler's theorem we have x w by x plus y w by y is equal to nu. U is the notation for function n, and n means the degree of the function is n plus half u. Okay, so this is by using Euler's theorem. Here is the question is verify Euler's theorem. So this is the by using Euler's theorem. Now we find the actual value of x w by x plus y w by y. That is, differentiate this u with respect to x and y and then take addition. So w by x is what? The derivative of this function is u into v rule. That is, first that x raised to n plus y raised to n, that is this function as it is. The derivative of this function is what? 1/2 x raised to 1/2 minus 1. That is, x raised to 1/2 minus 1 is x raised to minus half, and then that y raised to half derivative is 0 with respect to x. So we have this plus this quantity as it is, u. Derivative of this quantity is what? N x raised to n minus 1. Okay, n x raised to n minus 1. Here is. Okay, so multiply by x, we have this function x raised to minus half, and x raised to 1 is x raised to minus half plus 1, that is x raised to half, and here is x raised to n minus 1 into x raised to 1 is x raised to n minus 1 plus 1, that is x raised to n. And similarly w by x is this, and the multiplying by y we have this. Okay, and then adding 2 and 3, we have the addition of LHS as x w by x plus y w by y, and then take 1/2 as common, x raised to n plus y raised to h common. We have x raised to half plus y raised to half in bracket. Here is take x raised to half plus y raised to half as a common, n as common. We have in bracket x raised to n plus y raised to n. Take n also common. So we have then out of these two, take x raised to half plus y raised to half and x raised to n plus y raised to n as a common factor. So we have 1, and yet at this place we have n, at this place we have half plus n, or n plus half, and that is, this function is u. This is u. Okay, x raised to half plus y raised to half, x raised to n plus y raised to n is u, and therefore we have the same answer by using simplified method. That is, by using Euler's theorem, this is the answer, and by using actual calculation we have this answer. That is, both from 1 and 4 we say that Euler's theorem is verified. So u is this function, and then find the value of this. So first, this is the homogeneous function of degree 0. Why? Because if you denote this is u x y as a function of this, and then substitute x and y as tx ty. So what do we have? We have the same function t raised to 0, that is t raised to 0, actually 1 into the same function uxy. U tx ty is t raised to 0 uxy. This is uxy, and therefore u is the homogeneous function of degree n, degree 0, and therefore by Euler's theorem x w by x plus y w by y is equal to n u. N is 0, 0 into u is 0. So we have the answer 0. So this is the next problem. U is tan inverse x cube plus y cube divided by x minus 1. Then find or show that this. So u is this. So shift this tan inverse to LHS. We have tan u is equal to this. And this is the homogeneous function of degree 2. The degree of numerator is 3. Degree of denominator is 1. So 3 minus 1. 3 minus 1 is 2. So its degree is 2. And therefore by Euler's theorem, x dabba x of this tan u, either denote this tan u by z, as in the previous lecture we observed that this denote by tan u as z, and then x dabba z by dabba x plus y dabba z by dabba y is equal to n z, that is 2z. Then substitute z as tan u directly, and then x dabba dabba x of tan u is sec square u dabba u by dabba x, y dabba y of sec square u tan u derivative dabba u by dabba y, because this tan u is the homogeneous, is the function of u. So by you change into dabba u by dabba y, 2 tan u, then divided by sec square u. We have this answer, that is 2 sin u cos u, that is sin 2u. Already this problem is covered in the next previous lecture. U is log of this, and then log, shift this log to LHS. Then it is e raised to u. If you shift the log, then its inverse is exponential function e raised to u, or anti-log of u, e raised to u x raised to 4 by plus y raised to 4 by x plus y, and this is obviously degree 3. Degree of numerator is 4, degree of denominator is 1. 3 minus 4 minus 1 is 3. And then denote this function by u, either z or directly we say x dabba x of e raised to u, because e raised to u is the homogeneous function of degree 3. Y dabba y of e raised to u is equal to 3 e raised to u, and then e raised to u, derivative of e raised to u is e raised to u into dabba u by dabba x with respect to x, and with respect to y, derivative of e raised to u is what? E raised to u dabba u by dabba y is equal to 3 e raised to u, and then dividing by e raised to u, we have this answer. Okay, that is 3. U is sin inverse x plus y divided by root x plus root y. Then show that this. Okay, so shift sin inverse to LHS. We have sin u, and this is the homogeneous function of degree 1 minus 1 half, that is 1 half. Then by Euler's theorem, we have x dabba x of sin u plus y dabba of sin u. Denote this sin u or this function by z. Then x dabba z by dabba x plus y dabba z by dabba y is equal to n z. N is half, that is degree. Z is sin u. Substitute sin u, and then derivative of sin u with respect to is cos u into dabba u by dabba x. Sin u with respect to y is cos u dabba u by dabba y, 1 half sin u. Dividing by sin u, we have the first equation. Then differentiate this equation with respect to x and y, and multiplying by x and y, that are the equation number 3 and 2 and 3. Adding 2 and 3, we get the answer. Already this problem is solved in the previous lecture. What is the derivative of this function? This LHS is x dabba u by dabba square u by dabba x square plus dabba u by dabba x into 1, u into v rule, and y is constant. Dabba u by dabba x derivative is dabba square u by dabba x dabba y, 1 half. Tan u derivative is sec square u into dabba u by dabba x, because derivative is with respect to x. Then shift this dabba u by dabba x to RHS. Take common this is factor as a dabba u by dabba x as a common factor, and then multiply by x. We have this. Okay. Similarly, the differentiation with respect to y, x is constant. Dabba square u by dabba y dabba x, then u into v rule, y dabba square u by dabba y square into plus dabba u by dabba y, derivative of y is what? 1 half sec square u, tan u derivative is 1 half sec square u dabba u by dabba y, and then multiply, shift this quantity and take the dabba u by dabba y as common, and then multiply by y. We have this. Then adding 2 and 3, then LHS is what? X square dabba square u by dabba x square, then x into y dabba u by dabba square u by dabba x dabba y, this factor, and this factor becomes 2 times, because dabba square u by dabba x dabba y and dabba square u by dabba y dabba x both are same, plus y square dabba square u by dabba y square, 1 half sec square u minus 1 as a common factor. We have x dabba u by dabba x plus y dabba u by dabba y, and its value from equation number 1 is what? 1 half tan u. And then 1 by sec square u means 1 by cos square u. That take as 2 cos square u as a common, as a LCM. 2 cos square u minus 1 sin u by cos u. and then we have 2 into 2 4 cos cube u, and 2 cos square u minus 1 into 2 cos square u minus 1 is cos 2u into sin 2u. 2 cos square u minus 1 is minus 2 cos u, because cos theta is 1 minus 2 cos square theta. So 2 cos square theta minus 1 is minus 2 cos minus cos 2 theta minus cos 2u sin. We have this answer. Okay, that is what I have to prove. So next example, z is this x f of x by y plus g y by x. Then show that this. So this is the homogeneous function. This part is the homogeneous function of degree 1, and this is homogeneous function of degree 0. Suppose z is u, this is u, and this is v. Then u is homogeneous function of degree 1, and v is the homogeneous function of degree 0. So u is the homogeneous function of degree 1. We have x w by w square u by w x square plus 2xy w square u by w x w y plus y square w square u by w square by corollary of the Euler theorem, n minus 1 into u. But n is 1, therefore 1 minus 0, 1 is 0. So we have 0 answer. And v is homogeneous function of degree 0, therefore we have answer n minus 1, n is 0. So we have answer 0. And therefore x square w square u by w x square u plus v, 2xy, adding 1 and 2, we have this 2xy w square u by w x whatever u plus v, and then u plus v at this place is equal to 0 plus 0 is 0. So the answer of this is 0. That u plus v, that is z, we have the answer 0. This is equal to 0 as u plus y is 0. So these are some exercise problems. Solve all these exercise. Answers are also given. That is the, we have to prove the straightforward example, show that or prove the these are the problems related to Euler's theorem. Solve all these problems